Good morning, sir.
Good morning, sir.
Good afternoon, sir.
Good morning.
Good afternoon,
Good
sir.
morning, sir.
Welcome to all to the today's chemistry class. In the last class, we have studied about the various oxidation reactions. We have seen that the aldehyde and ketones undergoes two special tests which are known as the tolerance test and Fehling test. But remember that the aromatic aldehyde do not give the Fehling test, and both ketones never give this tolerance test or Fehling test. So to distinguish between the aliphatic and aromatic aldehyde, we can go for a Fehling test. Aromatic aldehyde do not give Fehling test, whereas aliphatic aldehyde can go for the Fehling test. Same way, ketones do not give either tolerance test or Fehling test, but ketones give a new test which is known as the haloform test, which we yesterday studied about. So when it comes to the haloform test, my dear students, aldehydes and ketones having at least one CH3CO group or CH3CH CO group, which on oxidation gives CH3CO group. So either we have these aldehyde or ketone or alcohol which have these two group, they undergoes the haloform reaction. So those ketones which are two ketone like 2-propanol, 2-butanol, 2-pentanol, 2-hexanol, or the alcohols which are two alcohols, let's look at them. They may be 2-butanol, 2-propanol, 2-pentanol, 2-hexanol. They all can 2-propanol, 2-butanol, 2-pentanol, 2-hexanol. They all can go for this haloform test. Even there is only a single aldehyde that gives this test, and that is the acetaldehyde or ethanal. Acetaldehyde or ethanal is the only aldehyde that gives haloform test. All the other aldehydes do not give haloform test. So if you want to distinguish between the aldehydes and ketones, you can easily go for the Fehling test or tolerance test, which is not given by ketones, but the haloform test is given by ketones. But apart from as acetaldehyde, all the other aldehydes do not give or do not undergoes the test and give you the yellow precipitates of iodoform. So this is how you can distinguish between the aldehydes and ketones, or the two aldehydes which are aromatic aldehyde or aliphatic aldehyde. So yesterday we have studied about the iodoform test. Even now let us study or understand the iodoform test with one more important examples where we are going to use all our knowledge. Remember, my dear students, that iodoform reaction or haloform reaction is used for detection of the CH3CO group present in a compound or CH3CHOH group which is present in the compound. This is what we could have even written in this manner. So this group, if it is present, or CH3CO group present in any compound, it undergoes the haloform reactions. Now a very important question, my dear students, for us to solve, and let us study this. Let us read the question and then we will solve it. An organic compound A with a molecular formula C8H8O forms an orange-red precipitate with 2,4-DNP. We have already studied that the compound containing carbonyl group, when they undergoes the reaction with NH2Z, that means the derivatives of ammonia or ammonia itself, they give the with 2,4-DNP, they give the orange-red precipitates. That means this compound C8H8O contains at least one carbonyl group. It also gives yellow precipitates on heating with the iodine in the presence of sodium sodium hydroxide. You know, my dear students, you have NaOH and you have I2. It will give you NaOI, which is a reagent that is for the haloform test or iodoform test, and yellow precipitates of iodine are obtained or on heating, yellow precipitates on heating. These yellow precipitates are generally because of the CHI3, which is known as the iodoform. So here we can say that this compound may contain either CH3CO or CH3CHOH group, but we are already aware that it contains the carbonyl group. So the probability of having CH3CO group is much more. It neither reduces the tolerance or fouling reagent. It neither reduces the tolerance or fouling reagent. That means it is not an aldehyde. Please remember, it simply says that the compound is not an aldehyde. The compound is not aldehyde. That means it is ketone. The compound as is not aldehyde and it contains the CO group. That means this compound is definitely ketone, my dear students, and a ketone that contains CH3CO group. This ketone contains CH3CO group. This is what we understand. It decolorizes the bromine water or Bayer's reagent on a drastic oxidation with chromic acid. It gives a carboxylic acid B. It also gives a carboxylic acid B if with a molecular formula C7H6O2. Please remember the molecular formula is C7H6O2. Identify the compound A and compound B. So here, my dear students, we want to understand about the compound A and compound B, and we have studied the various information, or we have gathered the various information about this compound. So now let us try to understand or the question once again. You know, we have one compound. That compound has got something which we know it as a. This compound has got compound A has got C8H8O. So my dear students, the compound has got C8H8O. This is what it is, the compound A. Now what happens, this compound has got CH3CO group present. CH3CO group present in it. We have confirmed it by iodoform test. It gives iodoform test as it gives the yellow precipitates. We have seen that it does not give tolerance or fouling test. That even makes it to have CH3CO test. This CH3CO is nothing but C2H3O. So let us minus C2H3O from this. So my dear students, when we remove C2H3O from this, what are we going to get? C6H5. You know, you are very aware that C6H5 is nothing but your phenyl group. This is the phenyl group. So my dear students, you can easily say that the compound is phenyl group with COCH3. You can even easily understand that the given compound is your benzene ring having C double bond O CH3. So this is how, my dear students, we can easily identify the compound A as acetophenol. These are the idea you can use and you can find out the compound by itself. I hope, my dear students, you understand. बच्चों समझ में आ गया है क्या?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, then let us omit this whatever the discussion, but let me read it for you once again. A forms 2,4-DNP derivative, therefore it is an aldehyde or ketone. Since it does not reduce tolerance or Fehling reagent, A must be a ketone. A respond to the iodoform test, therefore it should be a methyl ketone. Methyl ketone means this. The molecular formula of A indicates high degree of unsaturation, yet it does not decolorize the bromine water or Bayer's reagent. This indicates that the presence of unsaturation is due to the aromatic ring. That means aromatic ring is present. Compound B, being an oxidation product of ketone, should be carboxylic acid. The molecular formula of B indicates that it should be benzoic acid. You know what was the molecular formula? The molecular formula was C7H6O2. This is the molecular formula of our compound B, C7H6O2. You can see here we had a CC, that is the probable formula for C6H5 COOH. But we have already seen it some other way, that the compound contains phenyl ring, so it's benzoic acid. So compound A should be therefore a monosubstituted aromatic methyl ketone, and the molecular formula of A indicates that it should be a phenyl methyl ketone. The molecular formula of A indicates that it should be phenyl methyl ketone, or it is also known as acetophenone. And my dear students, you can see that this compound A, on reaction with 2,4-dinitrophenyl hydrazine, it gives the 2,4-dinitrophenyl hydrazone. This is phenyl hydrazone. 2,4-dinitrophenyl hydrazone, and same way when it is oxidized with H2CrO4, it gives us the benzoic acid, and with the iodoform and sodium hydroxide, it gives sodium benzoate as well as the yellow colored precipitates of the iodoform. So this is how, my dear students, we can solve such long questions. Generally such questions are asked in 3 marks, and you should know how to solve them. You will be in need to apply the various knowledge to solve a single problem. Now, my dear students, we want to study an important reactions. These reactions are known as the reactions due to alpha hydrogen. You know that the carbon bonded to the functional group, the carbon which is bonded to the functional group carbon or functional group is known as the alpha, and the hydrogen, if they are present on it, they are known as the alpha hydrogen. So the hydrogen which are present on the alpha carbon, they can be considered as alpha hydrogen and reaction due to alpha hydrogen. So if a compound has got alpha hydrogen, that means if the carbon which is alpha carbon having any alpha hydrogen, let us see what happens or what are the reactions we may get. Acidity of alpha hydrogen of aldehydes and ketones. First, we should know about the acidity of the alpha hydrogen which are present next to the carbonyl carbon of aldehyde and ketones. The aldehydes and ketones undergo a new number of reactions due to the acidic nature of alpha hydrogen. Due to the acidic nature, the aldehydes and ketones undergoes some reactions. The acidity of alpha hydrogen atom of carbonyl compound is due to the strong electron withdrawing effect of the carbonyl group and resonance stabilization of the conjugate base. Now let us understand this, my dear students, so that what is the meaning of this text that you can easily understand. You can see here that we have a carbonyl group. Next to the carbonyl group, the carbon, we call it as alpha carbon. On this alpha carbon, my dear students, we have a hydrogen present which is known as the alpha hydrogen. Now you must be aware of this. Now you know that this hydrogen is called alpha hydrogen. You can see, my dear students, that if some base attacks on this hydrogen, what happens? the electron of this bond go on this carbon, and this carbon. So this is what it happens, that the electron from this double bond goes on oxygen, and the electron of this bond go and make a double bond here. So when a base attacks on the hydrogen, the electron of this bond go and make a double bond over here. When there is a double bond formed here, the electron from this double bond goes towards the oxygen. So you can see here that due to the removal of hydrogen, there is a negative charge on this carbon. As the electron of this bond comes on carbon, there will be negative charge. That negatively charged electron goes to are shared between these two carbon, and you can see that the double bond is formed between these two carbon. If the double bond is formed, the electron from this double bond between carbon and oxygen goes to oxygen, and oxygen gets the negative charge. If the negative charge electron comes for the double bond between this carbon and oxygen, then the electron from this double bond goes on this carbon, and carbon gets negative charge. So you can see that when the base attacks on the alpha hydrogen, there are two possibilities. One possibility is oxygen get negative charge. Another possibility is carbon get negative charge. So here in the aldehydes and ketones, the carbon and oxygen, the alpha carbon and the oxygen present into the carbonyl group get the negative charge, and that is why the nucleophilic attack can be done in either of the position. When the nucleophilic attack is done on the either of the position, let us see how a special kind of reaction, which is known as the Aldol condensation, my dear students, takes place. First of all, we should understand the meaning of this word. This word represents al and dol. What is the meaning? Let us see. Aldol. This aldol is the word that is made up of two small words, ald and ol. This word ald comes from aldehyde and ol comes from alcohol. Now, if you find any compound which have both this aldehyde group and alcohol group, that means hydroxyl group and aldehyde group present into the same compound, such condensation, or if the reaction gives such compound, sorry dear students, such condensation or such reaction is known as the aldol condensation. So aldol comes from aldehyde and alcohol group. Aldehydes or ketones having at least one, remember, having at least one alpha hydrogen. This is the necessary condition for aldol condensation, that there must be at least one alpha hydrogen present in the reactants. They undergo a reaction in the presence of dilute alkali. Remember that the alkali must be dilute. Alkali is dilute. Because after this we are going to study the one more reaction, which is known as the Cannizzaro reaction. And in Cannizzaro reaction we use strong alkali, concentrated alkali. So here the type of alkali which is used should be dilute, my dear students, um, as a catalyst to form beta hydroxyaldehyde. See, hydroxy group is present, aldehyde group is present, and that is why it is known as aldol, or beta hydroxyketone, which is also known as ketone, respectively. This is known as the aldol reactions. Such reactions in which the aldehyde or ketone, if they possess at least one alpha hydrogen, they undergo a reaction and produce a compound that has both hydroxyl group and aldehyde group present with them. Such reaction is known as the aldol reaction. Remember, the reaction is done in the presence of the dilute alkali. We'll see which compound we can choose as a dilute alkali. So first, let us understand this reaction with the example, my dear students. You can see these. Here we have ethanol. Here we have another molecule of ethanol. I have just written the same molecule in two different manners. In first, I have shown this CHO group. This CHO group I have represented it as, my dear students, this is what I have represented as C double bond O, and H I have represented here. You know, due to the same way, my dear students, here this CH3 present here, that I have written as a CH2 oblique CH2 bonded H, and then there is an attack of this CH2 on this carbon. Now when the attack of CH2 takes place on this carbon, we get the complete compound, or these two compound, the way they are shown, they just get connected. You get this as a product. What happens, my dear student, is that this hydrogen feels, we feel that this hydrogen has combined with this oxygen. Not exactly, but you can see it all happens because of the presence of the alkali, so the mechanism is different. But still, this oxygen get one hydrogen and we get this product which has beta. On beta carbon we have hydroxyl group, and we have aldehyde as a functional group. So we get beta hydroxybutanol. And when we heat, my dear students, when we heat this product, from here we one OH group, and from here one hydrogen is being removed, and there will be a double bond formed between this. So you can see that here we get the double bond formed. This particular compound is known as the crotonaldehyde or but2-ene 1-al, and this is how the aldol condensation takes place. Once again, my dear students, when two aldehyde or two ketones, they react with each other, they produce the beta hydroxy, sorry, they produce the beta hydroxy compounds. On this beta hydroxy compound, which contains both aldehyde as well as the hydroxyl group, on heating it undergoes the removal of the water molecule, or it condenses itself by removing the water molecule into the alkenal. That means double bond is present and the aldehyde group is present, and this is how the aldol condensation takes place. The reaction is, or the product is known as aldol, or the reaction is known as aldol because it contains the aldehyde group and alcohol group present into the same compound, and that is why it is an aldol. As an alkali, we can use dilute sodium hydroxide, calcium hydroxide, potassium hydroxide, barium hydroxide, and other alkalis which are the water soluble base. Now, my dear students, we are going to perform we are going to understand the same kind of reaction between the two propanol molecules. So you can see that these two propanol molecules, I have represented them in a different manner, and this is how, my dear students, the propanol undergoes the reaction with each other in the presence of barium hydroxide. And the attack of one propanol on the other gives us the product 4-hydroxy 4-methyl pentane 2 on. And same way, my dear students, this 4-hydroxy 4-methyl pentane 2 on, when they undergoes the removal of water molecule, we get 4-methyl pent 3-ene 2 on, my dear students. So this is how, my dear students, we get the product formed. Here you can see that the attack of one propanol on other gives us first the aldol product, and then it gives us the alkenal. Alkenone, my dear students, because this is not even aldol. I made a mistake, I'm sorry. This is what it is, the ketol, and then we get the alkenol. So same way, both aldehydes and ketones undergo such reactions. So it's ketone and alcohol, it gives ketone. in above both the example, we know that reactants are same and they undergo self-aldol condensation or self-ketol condensation. Aldol condensation, that means self-aldol condensation. Whenever we use the word aldol condensation, we are talking about the self-aldol condensation. Please remember. The name aldol is derived from the names of two functional groups, aldehydes and functional group aldehyde and hydroxyl present in the product. So it's alcohol present in the product. Aldol and ketol readily lose water to give alpha beta unsaturated carbonyl compounds which are aldol condensation product, and this reaction is called aldol condensation. Though ketone gives ketols, compound containing a keto group and alcohol group, the general name of aldol condensation still applies to the reactions of ketones even. So even the reaction between two ketones is known as the aldol condensation due to their similarity with the aldehydes. So remember, my dear students, we have studied about the aldol condensation, and in this aldol condensation, my dear students, we do an attack in such a way that the alpha carbon, remember that there will always be an attack of alpha carbon on the carbonyl group. Remember that we always made the alpha carbon to attack on the carbonyl group, and the carbonyl group which attacks on the another compound. This carbonyl group is kept open, so the chain of that particular carbonyl group is written in this manner, so that we can easily cause the attack to take place into an aldol condensation. You can see here, even in the example of ethanol, this is the alpha carbon. So I have kept this alpha carbon open to attack on the carbonyl group. So here, somewhere where the attack takes place, we have kept the carbonyl group open, and here we make the attack from the alpha carbon only. Remember once again, my dear students, that whenever we have the aldol reaction, we allow the reaction to take place in such a way that the attack takes place from the alpha carbon. The other chain of carbon is not allowed to take place, and it goes into the branch, and the attack of the alpha carbon is on the carbonyl carbon, so that the carbonyl carbon is attached with the alpha carbon of the another compound. So when there are same type of reactants present into the aldol condensation, we call it simple aldol or self aldol. But if the two different compounds are used for such reaction, we call reaction as a cross aldol condensations. So now, my dear students, we want to study about the cross aldol condensation. Let us study about the cross aldol condensation. When aldol condensation is carried out between two different aldehydes or two different ketones, or one aldehyde and one ketone, please remember. So the reactant must be different. That is what the two reactions taking part into the aldol condensation, if they are different, such reaction is known as the cross aldol condensation. It is called cross aldol condensation. If both of them contain alpha hydrogen atom, it gives a mixture of four products. Please remember that the four products are obtained when the both of the compound are having the alpha hydrogen present on them. Cross aldol between two aldehydes. So let us first understand the cross aldol condensation that is taking place between the two aldehydes, my dear students. Let us move forward. Let me write a question for you. Write the products or the various products obtained for the reaction between the ethanal and propanal, or acetaldehyde and propanaldehyde. So we shall get four products. First product is the self-aldol of ethanol. Remember that we should get four products, and the first product that what we are going to get is from the self-aldol reaction of ethanol. So you can see that second product what we are going to get is the self-Aldol product of propanal. Product third we are going to get, that is the attack of ethanal on propanal. And fourth product what we are going to get is the attack of propanal on ethanol. So let us understand these products one by one. Here the ethanol attacks on the ethanol and we get but2-enol. This is also known as crotonaldehyde. This is what we have already studied, so we are not discussing it much. But here, this is the product that we get from the self-aldol of ethanol. Now, my dear students, you know about the propanol. This is the alpha carbon. We know that the attack must be done on the carbonyl carbon. So first, where the attack takes place, we have written the carbonyl carbon in this manner. Now we want to do the attack from the alpha carbon. So this CH3 group should be written as a branch. And the attack takes place from the alpha carbon. You can easily see, my dear students. So alpha carbon attacks on the carbonyl carbon. Now both this compound combine together to give us the beta hydroxy. We will get beta hydroxy products because this particular carbonyl group, this carbonyl group I am talking about, this carbonyl group is converted into hydroxyl group. So you can see that I am just combining this. I have written it all together, CH3, CH2C, CH2CH. You can see here, CH3, CH2CH, CH, CHO. So when we write this way, we can easily identify what products are we going to get. Just the change we have to make is, this branch will remain the same as usual here also, and this O has to be converted into OH. So this is how, my dear students, we get the beta hydroxy product, which is here 3-hydroxy through methyl pentanol. Now when we heat it, there will be a removal of one water molecule. We are very sure that the removal of water molecule is, first we will remove the one OH group and one hydrogen from this, one hydrogen from the alpha carbon of the attacker group. This hydrogen is being removed. So this hydrogen and this OH is removed and there will be a double bond between the second and third carbon, or alpha and beta carbon. So we get alpha beta unsaturated product. So remember, due to the aldol condensation, the saturation is between the alpha and beta carbon, or the second and third carbon in all the cases. Same way, my dear students, now we want to understand the product number 3. If you want to understand the product number 3, that is the product number 3 between the attack of CH3CHO. That is what it is going to attack on this carbon, in this compound. See, the compound on which there will be attack takes place, there we have to keep the open the carbonyl group, and that is why, my dear students, in propanal I have kept the carbonyl group open. Now from ethanol we are going to make the attack from the alpha carbon, and that is why we have written alpha carbon as CH2 bond H and CHO. Due to this attack, my dear students, there is a simple bonding between these two carbon, which are the alpha and beta carbon, into the next compound, and this O is going to be OH. Once again, there will be a bond between this alpha and beta carbon. This is going to be the alpha carbon of the product. This is what it is going to be, beta carbon of the product. Here you will get OH. This H is being removed, and this H has also will also be removed. So now you can understand that the product is very simple to understand. Here you have got this CHOH, which this is the beta carbon, this is the alpha carbon. From alpha carbon one hydrogen is removed. From beta carbon the hydrogen remains the same. It does not mean this hydrogen does not get removed, and we will get this. Now when we heat it, my dear students, the OH group and one hydrogen from the alpha carbon are being removed, and we get the alpha beta unsaturated product, or 2-ene. So we get here pent 2 in 1 al, because on the first carbon we have the aldehyde group. Now please understand the product 4, my dear students. It is the cross-Aldol attack of propanal on ethanal. Now remember, this is the alpha carbon. So this CH3 has to be written as a branch for this alpha carbon to attack on ethanal. To get such a product, you can see here, my dear students, that I have kept the carbonyl group of alpha ethanal open. At the same time, the alpha carbon should be attacking, and that is why the methyl group is kept as a branch, and then the attack takes place. Due to this attack, there will be bond between these two carbon, and here O will be OH. So you can see here the product that we get is 3 hydroxy 2 methyl 1 butanol. This CH3 remains as a branch. Now when we heat it, this water molecule and this hydrogen are removed, and we get alpha beta unsaturated products. So my dear students, overall we get these 4 products which you can see here, that by the reaction of ethanol and propanol, we get but2-enol, 2-methyl pent2-enol. These two are the products that is obtained by the self-aldol of ethanol and self-aldol of propanol. Apart from that, we get pent2-enol for the attack of CH3CHO on CH3CH2CHO. But when the attack of CH3CH2CHO on CH3CHO takes place, we get 2-methyl-but2-enol. Please remember that the alkene is always between the alpha beta carbon, and that is why it is the 2-alkene that we get mostly as a product. So this is how, my dear students, we understand the Aldol condensation, my dear students. Let us revise what we have studied. Today we have started our discussion of class with one of the problem. So we have solved this problem, and we found that to solve this particular problem, we need to use our knowledge of Fehling test, tolerance test. We need to use the iodoform, knowledge of iodoform test, and we need to use that the unsaturation is not possible because the compounds do not